In this video, we are diving deeper into Asus Aura Sync and Aura Creator's effects, clearly displaying the effects over multiple different connected devices so that you can have a look at each of them for yourself. Hey guys, James from TechLens here, and this video is actually additional content from the main channel video, where we critically analyze Asus Aura Sync and the much more advanced Aura Creator. In that video, we covered the most comprehensive feature analysis, the UI, the bugs, effect overview, everything. I'll have the main video linked in the description here for you if you haven't checked out already, but there is one thing that we really do need to stress before we continue with this one. There is going to be a lot of flashing lights in this video. If you are adversely affected in any way, shape or form, please consider not watching this video. It is an effect overview. There's going to be a lot of flashing lights. So please stay safe and let's take a deeper look at the effects within Aura Sync and Aura Creator. So as I mentioned in the main video, we are using Asus Armoury Crate version 5.1.5.0. And within Armoury Crate, we actually get access to Asus Aura right here. And for everything else, if we go into the update center, you can see right here what the version number is for each of the SDKs, different frameworks, other components within the Armoury Creator application. And in terms of Asus Aura Creator, this is version 3.3.4.0. And we will also be going into the Asus Aura Creator effects in a bit. But first, what we need to do is head over to Aura Sync and explain how all of the RGB devices have been configured through hardware, because this will allow you to understand how all of the patterns, how all of the effects are going to be reacting in the system. In fact, the best way to actually show you this is if we head over to device, go onto the motherboard right here, head over to addressable headers. Now this will allow you to be able to define the amount of LEDs that are in a connected device. And this is great for really customizing the effect to the devices that you have linked to your system. But what we can do to demonstrate how they're connected is if we set this to one LED within the strip, you can see that our first addressable RGB header has been split two ways. The first way that splitter is going to these addressable RGB fans. You can see that LED on the fan is lit up. But the second way of that splitter is being sent to this addressable RGB strip that's on the front. The reason being is that you can see how the effect will display on both daisy-chained fans, starting at this rear exhaust, going all the way down to the front bottom, and also on this addressable RGB strip. So if we set that back to 120 LEDs, we're going to go over to addressable header number 2, set that to 1. You'll see that our addressable header number 2 is also being split two ways. One way of the splitter is going to the G-Skill N-key pump block, and the other side is also going to the accent lighting running along the top and also down the rear back of the computer, where I would typically put it in a build. Which then brings us onto the non-addressable headers. So what we're going to do is go through this calibration process. We are using RGB header number 1. If we go next, you can see that we're now calibrating the RGB strip down at the bottom, the non-addressable one right there. And there's also another side of that splitter that's being sent to the left side of the radiator back there. Again, the reason being is that's typically where I would put it in a build for accent lighting, and being on the side of the case, you can also see it a lot better for demonstration purposes. So what we're going to do is go over to the main screen of Asus Aura, and you'll see here that we have sync devices. We have the motherboard, the GPU, the memory, and the addressable LED strips. Now the addressable LED strips, they're kind of misleading. It's essentially anything that's connected to the addressable RGB headers of the motherboard, and it may not necessarily be an RGB strip. But what we're going to do is run through each of these, how you can control them and what effects you actually get, including, right down here, the Asus Aura Creator application, which looks like this. We're going to cover this in a lot more detail in a bit, but this is a timeline-based animation creator for your RGB effects, which is a fantastic implementation compared to other motherboard manufacturers' software. So we're going to cover this in a lot more detail in a bit, but first we need to go over the global lighting effects. Now what I mean by global lighting effects is when I choose something like static, everything turns to pink. That's the memory, the G-Skill pump block, the fans, the GPU, all of the RGB strips. They are globally set to static to pink. So in global lighting effects, you actually get 14 different effects plus off right here. Now the astute of you will actually see that there are 9 effects listed here, but you do get 14. The reason being is because something like music right here, you've got multiple options within music, and I will count these as unique effects because I have done them for other motherboard manufacturers. So going through the list, what do the effects actually look like for the global lighting effects? So let's start with static. right here. And within static, you do get color control. If I click that, you have this color wheel right here, as well as RGB values right there. So if we set that to 0 and hit OK, that is now 100% green. We can also change the opacity actually just by changing this value. So if we put that down to 100, you'll see now that it has a lower opacity, which would be great if the lights are too dazzling for, say, your bedroom when it's dark. So moving over to breathing, which is one area where I really do need to highlight something. Yeah, you definitely can see that on camera. So the breathing lighting effect is meant to be a smooth breathe in and out. What you're not meant to see is that harsh stepping between opacity levels. That looks atrocious. You can change the speed. So let's see if we can try and improve upon that. It's better, but it's not perfect. And if we turn it up to 100%, that I would argue is significantly worse. So what we're going to do is go over here and turn on performance mode. Now what performance mode seems to do, if we do task manager, is it increases the poll rate for the RGB, and increasing the poll rate will increase the amount of load on your CPU. And right now the lighting service is taking up almost 10% of the CPU's resources, which is extremely high. If we turn performance mode off for a worse experience RGB, this will drop quite dramatically, almost by 50%. So it's going to be up to you whether you want a smoother transition or if you want to claim back some of your CPU's resources. It might be a good idea to say turn it off whilst you're gaming so that you can get as much FPS as possible, and then turn on performance mode when you're, say, browsing the internet and just watching YouTube or something. So for the sake of this testing, we will leave performance mode on so that you get the best representation of the RGB solution, but do bear in mind that this is what we're using for all of the testing within this video. So going back to global lighting effects within breathing, you'll see here that we do get a random checkbox. Now what that seems to do is change color with each breathing cycle. You'll see here red, pink, more pink, less pink, yellow, blue, different blue. But what we're going to do is turn this down to half speed and show you that you can also use the color picker. You just have to uncheck random and then you can use this. So now that we've checked out static and breathing, it's time to move on to strobing. Now strobing seems very similar to the breathing effect, but it seems to pulse in the new color before the previous color has finished its animation or transition, which is kind of a unique effect. And with strobing down here, we do still have access to random like we did with breathing. But again, if we turn that off and have that set to red, this is what it's going to look like with one color. So after strobing, we have color cycle. And with color cycle, we don't get any control of it whatsoever. No color control, no speed control, no nothing. The effect is purely handled within the software with no customization. And color cycle will just softly change between one color to another for every connected device. Rainbow, on the other hand, has some really interesting control. You'll see right here that we have a drop-down box with 8 different patterns inside it. Now these are predefined patterns through the software, but you have your traditional RGB, which I think is actually really quite nice. You'll notice that there's only about 1 LED per time for the red LED moving along there right now. So what this means is that it's not just a 4 block of one color or a 4 block of another. It's not unimaginative. Somebody actually took the time to implement that, stylized it this way. So I'm actually really happy with the implementation of this rainbow effect, especially compared to some other motherboard manufacturers' RGB software. So inside the patterns, we essentially have a high opacity red going down to 0 opacity. We have blue to red to low opacity to blue to red repeat. After that is sort of a more orange peach sort of cycle. I tell you what, we'll change it onto that. Kind of looks more white than anything else. This green to blue is probably going to be quite nice. Yeah, I do actually quite like that. But we'll turn the speed down to halfway. I think that's a lot more subtle and a lot nicer. So next in the list, we have Starry Night. Now, Starry Night is actually a really nice effect that I do like, and I really like the customizability of it. You'll see here that we have background color and effect color. So what we can do is go into this color picker and say choose a more soft white. If we do 100 for the value for all of these, you can see that we essentially have a base color of a light white, and then independent LEDs are going to be lighting up red softly within that white strip. And I think that's actually a really cool implementation. And I love the fact that you can control each color independently. You can turn the background off right there if you didn't want a background color, and you can also set the foreground color to whatever you want really. You can also go random right there with also speed control here. So let's turn it down to its lowest, which I would argue is probably still a little too fast. Next up, we have music-based effects. This is not just one effect in itself. A lot of these effects are quite similar, arguably, but they are 4 unique effects independent of one another. So what we're going to do is play some music and test some of these effects. that actually looks reasonably well timed to the music, which is not something that I can say about every motherboard manufacturer's RGB software that we tested. Most of them have been atrocious. That actually looks like it's somewhat to the beat, which is a pleasant surprise. But I'll let you guys be the judge of that, because all of these videos in frame are perfectly synced to one another via timecode. So what you're seeing and hearing is exactly what I'm seeing and hearing. And within the wave effect, you also get access to these rainbow animations right there, all 8 of them, as well as color cycle, which you are viewing now. And for context, this is the rainbow one. It essentially, unlike the color cycle where it changes the whole strip a different color, is going to produce a rainbow effect sequential down the strip or connected device, as well as pulsing in time with the music, or at least trying to. And if you have issues with music not pulsing accurately to the beat, you can increase the sensitivity right here. So moving on to the next one, which is waterfall. You get access to the same controls as you did before, say color control right there, rainbow effect control and color cycle, but it does produce a very different effect for the music. And then going on to beatbox right here. Again, the same color controls right there as well as color cycle, but we have random here instead. So let's take a look and see what random does. So it seems to be producing like a flash of one color to fade to then flash a different color, whilst also performing the music effect. If anything, that looks incredibly erratic. In fact, if we turn off the music, is it still going to do something? No, it definitely needs music. And then we'll move on to audio spectrum, which is the last music-based effect. And that's what this one looks like. We don't get random anymore, but we do get the rainbow effects, all 8 of them right there. They are now back and included, as well as we still have the color cycle right there, as well as independent color control that you can set yourself. So as much as I love Crab Rave, you're gonna have to be quiet. Cool, so let's move on to the next effect, which is Smart. So inside Smart Effect, you actually get 3 different effects based on CPU temperature, CPU usage, as well as GPU temperature. So let's start with CPU temperature. Essentially, it changes color based on the temperature of your CPU. So if your CPU is under 40 degrees C, it will be green. Over 40 degrees C, but under 60, it will be yellow. And over 60, it will be red. And you can actually move this slider to anywhere you want, and you will see right above is being updated. So now that we move this down to 28C, we're actually yellow. So CPU usage is very similar, but based on CPU usage as a percentage right there. And then GPU temperature in degrees centigrade. And then moving on to adaptive color. Now, adaptive color is actually really quite interesting. What it's going to do is essentially read your screen, see what color the pixels are, and take an average to display that color within your system. So you'll see here, if I open up YouTube, all of the lights change to primarily white. And I can imagine for gameplay, that could be really quite cool. And then of course, some people's favorite effect, no effect. Okay, now we've updated a couple of these components within the Armory crate. I think it was this framework service and also the Aura kit for the memory, with then 2 new version numbers right there. This should now give us access to the GPU. And within the GPU, we actually get some different effects compared to global lighting effects, which I will go through with you now. So I have set up another camera. It's not something that I typically do, but the Asus logo on the side of the GPU that I'm using the RGB just really isn't coming out strong enough or showing any sort of effect well. So what I've done is I've set up a different camera angle so that we can see the front of the card. I apologize, this isn't as good as it should be or it usually is on the channel, but hopefully you can still get a pretty good representation of how it should look. So for static, we of course get color control right here. Choose any color you want, change it over to a green, but you also get LED brightness control, which is a little bit odd if I'm completely honest, because you can just change brightness right here, like that. But if you didn't want to do that, you can just set 100% on the color value and then change the brightness right here. So moving on to breathing, it's exactly as you imagine it to be. The interesting thing is we don't get speed for breathing, which I thought was quite odd. That's your only breathing level with that sort of speed. So it'd be nice to get speed control. Again, you will only get brightness and you can change it to whatever color you want. But in terms of color cycle, again, we get no customization, similar to how we did in the global lighting effects. And what it's doing is essentially cycling between colors with a smooth transition between them, with every single LED within the GPU lighting up the same color at once. When we go over to rainbow, we do get speed control back. We've got slow, normal, and fast, but we don't get the ability to change the rainbow animation like we did in the global lighting effects, but we do get direction control. And this is something that I think a lot of motherboard manufacturers need to take note of. Direction control could mean a lot for somebody. There's been a few effects within a lot of different RGB software where I thought to myself, I really like that, I just wish it went the other way. So direction control right here, you can reverse the direction of the animation, which I think is a really nice touch. As for Comet, what it's essentially doing is sending a few of those LEDs down the RGB strip that's wired within the GPU. And you can of course change that color to whatever you see fit. If we change it over to there, that's almost 100% red. As for glowing yo-yo, we actually don't get any customization for this effect too, but I really do like this effect. It essentially has an RGB sort of background glow to it, but then pulses an LED through the GPU whilst also breathing multicolored. I think that's a really unique and really nice effect. Starry Night, one of my favorites. Again, we don't get any customization of this effect, and what's interesting is it seems to be a default orange, which to me is kind of an odd choice. I think the default used to be red, but if it's a starry night, wouldn't the default be white? Anyway, Dash and Flash has no customization options, but what it seems to be doing is a soft color cycle whilst also sort of pulsing, and while performing that color cycle, it's also flashing through the GPU, which I think is quite unique. As for strobing, we do get color control back right there, but we also get LED brightness control. But essentially what it's doing is a long flash of all LEDs given a specific color that we've set. And then the last one right here is Aura Sync, to sync it back to whatever the main lighting that we set for the system is. So if we change that back to rainbow, for example, we get full rainbow back. Now at this point of the video, what I would typically do is go through the memory effects and what they look like in the system. The only problem is you get no unique memory effects. You can't control them independently from everything else in the system. The way that you do that with the GPU is by going here, and you can set a different effect to whatever the global effect is, but going into here, we can't do that with the memory. If you did want to set the memory to be something different compared to whatever the global lighting effect is, you could potentially just unlink it from the global lighting effects like this, and then use G-Skill's RGB software to control the memory. But before we check out the most advanced way any motherboard manufacturer has allowed you to customize your RGB solution, we need to check out one more thing. What about third-party integrations? Now what I mean by third-party integrations is essentially any other separate company or product like Hue or Nanoleaf, being able to control them through Asus Aura. And you'll see down here we have Hue connection. Let's search for devices. Bear with me, I have to go press a button. Aha! Alright, so that was actually a pretty pain-free experience. We now have Hue linked into Asus Aura. So this is part of the global lighting effect, so let's see if we can change it. We did get a warning message right here. Hue can only sync with other devices under 4 lighting effects: static, breathing, color cycle, and dark. But if we go over to Aura effects, let's change this to static, red. Oh, there we go. Lights have changed. Now this is something that you should probably consider if you are integrating Hue devices into RGB software. Essentially, what devices do you want to integrate? Because every color changing bulb in my house, I assume, just changed to red. That's not a good experience. So what that means is that you're going to have to get a separate Hue hub for the devices that you want to be linked within the Asus Aura RGB software. Otherwise, all of the lights within your house are going to turn that color. But then if we go onto breathing, you know what, this is a bit harsh for me. Wow, okay, that is a very different time to breathe. Or is it? Did it just take a while to update? No, it's a very different time to breathe. What were the other ones that we get? Oh, let's go on to color cycle. Let's do it. Color cycle. Oh, that hurt. Okay, let's stop this. Okay, let's go over to static. Let's go, it's kind of a blue. It's what we had before. It's kind of more of a pinky blue. Okay, and then go sync devices, unlink that, and then go Aura effects, go rainbow. Or for example, we did have breathing, and that should mean that my lighting is now not going to breathe too. Perfect. But now we need to talk about the prism in the room. This is Asus Aura Creator to create unique lighting effects between synchronized devices. It sounds interesting, it sounds pretty exciting. And if we click that, I've already installed the application, so we're just going to maximize this. So once it's open, we get this screen. Now don't worry about no devices available. This is essentially any keyboards or mice that could be controlled through Asus Aura. Asus have their own lineup of peripherals, so that would work with this. But if we go over to PC components right here, we can see our addressable RGB strip strips, the motherboard as a whole unit. It would have been nice to see that break out between, say, PCH and rear IO, which would be similar to how it's broken up here. You see, we actually have independent control of either individual LEDs or banks of LEDs right there within the GPU. And then we have memory modules over on the right hand side. So these are all your devices that can be controlled through the Aura Creator application. And I've gone into this in a lot more detail, how this application actually works in the main channel video. So I'm not going to be covering a lot of that in here. But what I will do, as this is the effects video, is cover the effects, of course. So what we're going to do is create a new layer encompassing every single device like that. Set that as a new layer. You can set them independently as new layers like this. And what I recommend highly is that you name your layers, otherwise you're going to have no idea what's doing what. This was Mobo all. And what we're going to do is drop a couple of these effects in the timeline. This is timeline-based effect editing, which is really advanced for motherboard manufacturers' RGB software. Kind of depressingly advanced compared to other RGB software, but advanced nonetheless. So what we're going to do is drop every single one of these in. So these are all the standard effects that you can use within this timeline animation, starting at static, breathing, color cycle, rainbow, strobing, comet, star, and tide. Star and tide are new, so it'd be interesting to check them out. But as for static, we get limited options. Color option, similar to what you saw before. We'll keep that as red. For breathing, you have single color, you have multicolor breathing, as in breathe one to the next, or random between set values, which you can change right here and here. So if we decide that we want a pink to a blue, and then set that to, we'll keep that as mid speed. And then over here, we have color cycle, which I'll change to 100% speed. And then for the next bit, we have rainbow, which is that standard rainbow pattern, but you can actually edit it between different values right here and here. So if you want, say, like more greens, we can just exaggerate the green essentially. Keep it at 100% speed. And we also get angle right here, which I assume changes the direction the effect will actually display across multiple different devices. And down at the bottom, we have special effects. So we can turn that on and say go inside out, outside in, or reverse the direction. So what we'll do is set that to outward. As for strobing, we have single color, multicolor. Let's change this to 2 colors right there and make that slow speed. Going over to comet, where we have single color, we have random between 2 predefined sets, and also speed and angle. So let's see if we can go down for this one, high speed. And then for star, again, random, where we'll choose between green and yellow with a high speed. And then for tide, single color, which we'll keep on red, we'll go slow speed and then reverse the angle 180. So now that we have every effect set up apart from these, I'm going to show you those in a second. What we'll do is play the timeline, see how that looks. Static, breathing now. Nice. All right, this is color cycle, and then this is rainbow. This one is strobing. This one is comet. Star right here. Tide is kicking in now. There we go. And if you want to see what angles does better, what we're going to do is just show you tide here, and I'll extend this out. You can extend the time of any of these. You'll see how that's animating left to right essentially. You can see it in the screen bottom left. But then if we stop that, what I'm going to do is have it on tide 180. So you'll see in the screen on the bottom left and what you're actually seeing on the computer. It's starting at the memory, there we go, and then animating across the GPU, the motherboard, and the addressable RGB strips. And you can get really creative with stuff like this. If we duplicate this layer and then move back over to here, so what this means is that anytime that there's an opacity change in the track above it, the white is going to start shining through, which is really cool and allows for so much customizability that you can just go boom. So it's going to be static red, then it's going to be breathing, and you'll see that the white is breathing in and out as it's changing its breathe. So what I'm going to do is clear the track above and keep that static down below and tell you about these. These are sync with effects. Like I showed you before with music, smart and adaptive color, they are essentially the same thing, but you get better control of them because you can have multiple layers doing multiple things. The nice thing is you actually get control of the colors, which you didn't before. That's so much better, and you can turn them off and on. Oh, and you can make them breathe and strobe. There is so much more control in here. That's just insane. Okay, so mid-range to there. And what's mid-range? So we're probably going to be like around this area. Let's change this to red. Oh, I need to increase that. And there we go. That's exactly what I wanted to do earlier. which is fantastic, and you can turn them on and off. So then if we play this, that's essentially the temperature of our computer. But because we set red to be the low temperature, it's now red. That is so much better. And then if we set that over to breathing, you can see that the white is fading in because we essentially have that as a track underneath it. So every time that the opacity of the red gets lower, the white is going to start breathing in. This is actually very advanced for motherboard RGB. So what I've done is I've gone through this list and also all of these, and what you essentially get with static right here is the ability to change independent colors, which is really quite nice. That's really what I wanted in the original global effect. But if you change it over to breathing, you've got essentially low, medium and high values. So anything under 40 is low, anything over 60 is high, and anything in between. And then you can set what they do independently. So you can have, say, red for low or whatever color you define. And then for medium, you can essentially have it breathe between two different colors. And then for high, you could just choose random between a defined color set, essentially. And then speed down at the bottom. And this is the same for strobing for all of them within this list. So what we'll do is keep it to CPU temperature. We'll have it on breathing, and we're probably going to be in the low values. So let's do a random between all colors. As for adaptive color, we then get this box right here. And what we can do is essentially choose an area of the screen that we want to capture to then display that color on the rig, on the computer in front of us. So we have to do print screen, which is that one, and then load screenshot, which is this one, and then choose an area that we want to capture. Maybe something like that right in the middle, and then hit save. And then you have a couple different options at the bottom. How do you want to display the color? The average color in the detection area, or the most common color in the detection area. So we're going to choose that one and set that timeline back to there. So if we hit play on this and then Trusted Crabbrave, I wish it was better, but I'm not entirely sure that we had this issue within the global lighting effects, where we did see the same adaptive color effect. But coming back to the Aura Creator software, I am really impressed with this, and I talk about this a lot more in the main channel video, and 1,000 other things, like what RGB stays on when you put the computer to sleep. Can you control it through BIOS? Can you uninstall Asus Aura and still keep the same effects? So thank you very much for watching. I hope you found this video both interesting and informative. If you haven't checked out the main TechLens channel or the Asus Aura Sync and Aura Creator analysis, make sure that you head down to the video description below. You'll find it there. Otherwise, like, subscribe, all that good stuff, and guys, I'll see you in the next video.